Hello and welcome to Cyber Skills Live. My name's Daniel and I'm a climate conscious engineer. You're joining Craig and I for this very special Cyber Skills Live. Now, Craig and I love everything tech and data. And today you're going to be using data science skills to help fight climate change.
Thank you for joining us. We have groups joining us today from across the world and across Scotland as well. This is your chance to learn about data science skills and climate change in the classroom. You're about to get hands-on with data. So what is data? Well, data is information. It's things that we know. It's things like facts or numbers, things that we can measure. And data science is being able to collect that data, being able to understand it and use it to make decisions. We need more people who understand how to work with data and how to use it to make better decisions. But can we use data to save our planet?
We're in a climate emergency. To give us the best chances at reducing the impact of climate change, climate scientists have stated we need to secure global net zero by 2050 in order to keep the global temperature rise under 1.5 degrees. Now, to do this, we need to accelerate the phase out of coal. We need to curtail deforestation. We need to reduce our usage of fossil fuel transport, and we need to encourage investment in renewables. That's what we're going to focus on today, renewable energy.
You'll use real-world data sets to create a proposal for a renewable energy system for your school. You'll need to work with energy usage data, geolocation data, satellite imagery and Earth observation data collected by NASA.
So, are you ready to use data to save our planet? Let's plug in the numbers and use data science to reduce your school's carbon footprint. Thanks for joining us. We are really excited about this one. You are going to be data scientists exploring how renewable energy can reduce your school's carbon footprint. What you need to do now, if you haven't already, is go onto cyberskillslive.com on your computers and click Start the Live Lesson.
Yep, all you need today is a web browser. So you're going to go to cyberskillslive.com and you're going to click Start the Live Lesson. So the activity we're doing today is called Plug in the Numbers. You'll see it at the very top of the page. So if you haven't already done that yet, go to cyberskillslive.com and click Start the Live Lesson. Once you've gone to the website and signed in, we will be tracking your progress and we'll also be giving you hints and tips along the way. So don't worry if you fall behind or you get stuck, or if you've never done anything like this before, Daniel and I will help you catch up. So when you sign in, select your school name from the drop-down list and type in your first name.
So I can see lots of you already joining. It looks like in the top corner we've got 17 players just now, and it looks like some of you are playing in groups and some of you are playing individually. Both are, of course, okay. We're going to be following along with your progress, giving you hints, shout outs, and guiding you through plugging in the numbers. So speaking of shout outs, Craig, I think we should say hello to some of you that are taking part and playing along today. So a big hello and good morning to Pathhead Primary School and Longstone Primary School. I can see you're playing as well. Good morning. Hello. Thanks for joining us. Welcome to Plug in the Numbers.
Give us a nice big cheer in your class when you hear your school name mentioned. We want to be able to hear you from our digital dens here. So let's have a big shout out to Cookenzie Primary School. Hello. Thank you for taking part. And I can see that there's a few people joining us today from Stony Hill Primary School. Thank you for taking part. Hello. And also we've got people joining from the East Lothian Hub. Thank you for taking part as well. So yeah, it sounds we've got primary schools as well. I can see Roslyn Primary School as well, Daniel. We've just started playing too. So yeah, we've got a good mix. So Daniel, what is it we're doing today?
Yeah, so in this session today, we're going to try and answer a question. And the question that we're going to try and answer is, how much energy could a solar panel on the roof of your school generate? And what impact would that have on your school's carbon footprint? So we're going to use data to answer that question. Now, all the different schools taking part today are going to have different answers. I reckon one of the schools in Fife might have a slightly different answer to a school in Mid Lothian because they've got maybe slightly different weather, slightly different amounts of sun, different sizes of schools. So we're going to help you gather that data. We're going to help you analyze the data, and then you're going to do some calculations to come up with an answer based on your school's real data. So what you need to do is follow the instructions on your screen to start the investigation. And we've got a virtual data scientist and climate activist called Sunny, and she's going to guide you through the process.
Daniel, this is going to be so much fun today. You're going to get to play with real world data, do these calculations, and we're going to share some of your answers and what you're doing, because we want to be able to see your results as you work through this activity. So if you are a teacher, you can tweet us what your class are doing at data_schools, and you can use the hashtag CyberSkillsLive. We love to see your messages, your photos, and the results of some of your calculations today. Thank you for joining and taking part, Daniel. We've got over 30 people joining so far. I think there's more people joining I can see on my screen as well, but we're just getting started. If you've just started watching, you go to cyberskillslive.com and you click start the live lesson. So Daniel, the data collection has already started.
It has. So when you started, you had to type in your name and you had to choose your school, and then you also had to pick an avatar. So let's take a look at our activity feed. This is where we can see all of you taking part and all of the data that you're sending in to us. So I can see Miss Hay, you have been telling us how much electricity is needed for a typical school day. Tibby at Longstone Primary School, you have been identifying the units of a data set.
Ryan from Longstone Primary just started doing the activity as well. So well done for everyone who's taken part, and someone from the University of Edinburgh is also taking part today as well, answering through these questions. Archie and Fizza are also taking part today, and Caleb has just started the activity as well. So I can see a lot of you are just starting and joining. Don't worry, we're just getting started. You've not missed anything yet.
So also at the start, we asked you another question. We asked you how you got to school today. So we were collecting that data by asking you the question. And now what we can do that we've got that data is we can analyze the results to try and understand what mode of transport was the most popular with you all today. So Craig, I think we could take a look at that data. So let's bring up the pie chart. So here it is.
So one way we can visualize data so that we can better understand it is to put it onto a chart. So rather than having like a big list of all your answers, we can put it on a chart like this. And this is an example of data visualization. So rather than me just reading out how many votes for each type of transport, we can show you the results on a chart like this and make it easier to understand. So Daniel, you've got a better view of this than me. You tell me what can you see from this chart?
Yeah, so I can see that the most popular option is walking, running, or rolling. That's the big orange section. But I can see that some of you came by car and some of you came by bike. So it looks like car is the least popular, bike next, and then walking, running, or rolling being most popular.
Did anyone travel by train to school today?
Not yet, but if you did travel to school by train, you haven't answered this question yet. When you answer it, this will update. This is live data. So I can see that the pie chart has changed a bit since I brought it up, because that says more people are joining and answering the question. So we'll maybe come back to this in a bit, Craig.
Yeah, excellent. So what are we investigating today, Daniel?
Yeah, so the real goal of our investigation today is to find out how much electricity we could generate using solar panels at your school. But we've got some other questions that we need to answer first to be able to answer that big question. So the first question that we want to know the answer to is, how much electricity does your school need? How much electricity does your school use every day or every year? Now, there's a few different ways that we could answer that question. We could look at the electricity meter and then go back a year later and see how much it had changed by. That's how much you use in a year. Or you could ask your head teacher to show you the electricity bill. That's one way that you could
Yeah,
find
good luck
out.
with that.
That's one way you could find out the amount of electricity that your school uses. But, if you want to know how much it uses over a whole year, looking at the meters no good. It's going to take too long and you might not get given the electricity bill. So as data scientists, we're going to need a different way. And the thing is, there is a different way we can do it. We can use something called a data set. And a data set is going to tell us what we need to know. Now, a data set is a collection of data. It's a series of numbers that someone else has already done the research for us, and then we can reuse what they learned and discovered. So what we found was most schools use a really similar amount of electricity, at least within Scotland. And there's data sets available that have really detailed information on the amount of electricity that schools are using.
Yeah, so we're going to use smart meter data to give us an idea of how much electricity a typical school might use every year. So that data has been collected by someone else. So it's been collected by Dundee Council. Shout out to Dundee Council, and they've shared it so that other people like us can use it. So how it works is they set up electricity meters in every school in Dundee, and they recorded how much electricity was used every hour for a whole year. And they put all that data into a structured format. So in this case, it's a spreadsheet, and they put it so that anyone could download it and use it. And that's the real life data that you're using as part of this activity just now. And because that data is available for anyone to use, it's what's known as an open data set. Daniel, why is it much better to use something like an open data set than it is to sort of collect it yourself?
Yeah, I think the main benefit is saving time. If you were to do it yourself, you'd have to buy equipment like that smart meter. You'd have to set it up for a whole year before you could do anything with it. We want to know the answers right now. And if someone else has already got the data, why not just use that already? Because open data, as long as it's high quality and as long as it's been recorded correctly, which this has been, it can get reused by lots of different people for lots of different purposes to answer lots of different questions. So for example, this data set that you're looking at just now about the school usage in Dundee schools, that might also get used by electrical engineers who are planning a new school or an extension, because that will give them an idea of how much electricity that might need. They have to know how big a substation to build. They need to know how thick the cables need to be to transfer all of that electricity. So yeah, open data is really useful. And as data scientists, it's one of the main sources of data that they work with.
I can see, Daniel, a lot of people on the activity dashboard are already working through this. I can see that the P6 data team have been working through that data set, and people from Longstone Primary, Cockenzie Primary School as well, working through this just now. This is brilliant as you're all going through it, and Edinburgh University are also taking part and catching up there too.
Craig, I can see here that Ethan and Robbie have been telling us why less electricity is used at the weekend. Now, I think we could take a look at the data set on the stream here, and we could see what's going on, see if we can spot any patterns and understand it. So,
new catchphrase, Daniel. Let's look at the data.
Let's look at the
Bring
data.
It up.
So here is the data, and we've chosen Braveview Academy. It's a really typical school in Dundee. So this is their daily electricity usage taken from their smart meter in November and December. That we could change it and look at an even wider period of time. We can look at it here. So, Craig, it looks to me like it goes up and down really quite regularly. Like it's flat and then it goes up, up, up. Mm-hmm. And it looks like it's up for 5 days and then down for 2 days and up high for 5 days and back down low for 2 days. Now, I can tell you that when it's low, that's the Saturdays and the Sundays. I know it's probably quite hard to read on my screen. So it looks like the electricity usage is quite high Monday to Friday and quite low Saturday and Sunday.
Okay. Yeah, so that's quite interesting, isn't it? So looking at this data here, Daniel, you've started to look at, trying to answer that question. Why do we think that the data might be higher for a couple of days, 5 days during the week, and less at the weekend? So that was one of the questions that we asked you. We said, why do you think electricity is used at why do you think less electricity is used at Braveview Academy at the weekend? And Daniel, I've got some answers here from people who've been taking part. So Ethan and Robbie say because there's no need for it at the weekends. And Aaron and Nicholas say because there's no one there on the weekends. The P6 data team from Roslin Primary said less energy is used at the weekend because the school is empty. There's no equipment, the lights are not on, and the minimum level for usage of alarms and some heating systems and security lightings. P6 data team, that's the kind of detailed answers that we need. Thank you very much.
That's going to be really useful in our report, is to keep those detailed answers going. I can, yeah, and Craig, see here that Miss Hay said there's no pupils. Maybe said there's no humans in the building.
Does that sound like a good thing, Miss Hay, having no pupils in the school at the weekend? So yeah, I think what else have we got here? I'm just having a look at some more of these answers as they come through. Just refreshing them on my
Archie and Fizzer are saying because people don't come to school often at the weekend. I think we've kind of got it, Craig. You know, if there's no pupils at school at the weekend, then they don't need to have the lights on, they don't need to have all the computers on, the heating probably doesn't need to be as high. There's just no people using the electricity and using the energy, so I suppose it makes sense that there's much less used at the weekend.
These are all good answers. As people finish this off, Daniel, I thought maybe we could give we did ask another question a wee bit earlier on, and I just wanted to give more people to give some answers to this. So we asked people to think about, you know, the climate emergency, and we asked them to tell us a change that they're making that's going to help them reduce their carbon footprint. And I'm going to give a shout out to some of these answers just now. We'll maybe do some more later. Caleb from Longstone Primary School saying they're going to use less electricity. And Rachel from Longstone Primary, she's not going to use a car as often. And who else have we got here? Let me have a look.
You can see here that Primary 5A at Cockenzie Primary School, they've given us lots of changes that they've made, Craig. They've said they are recycling, they're using paper fully before taking a new piece, they are active travelling, they're eating greener, they aren't littering. Those are all really good things that you can do to help reduce your carbon footprint.
And we've got some from teachers here, Daniel. Miss Hay has been planting trees. Well done, Miss Hay. And Mr. Johnson has been making sure the lights are switched off as well. So, yep, these are all great answers here.
Kingfisher, eating greener and not wasting food. Rachel, don't use a car as often. Craig, there's loads of really good suggestions here. I think this is something we could come back to.
Primary school pupils here driving, by the sounds of it. I take it they're not the ones actually driving.
Yeah, there's a lot of people saying that using the car less.
These are all good steps to take. So, Daniel, I think we've kind of gathered the information that we need here. I think we're ready to move on to that next phase.
Yeah, I think so too. So, you know, now what we've done is we have thought about how much electricity we have to supply. And we've got an answer, we've got a number that we can use going forward. So let's think about where we could get that electricity from, because your school probably gets its electricity from the grid. Now, the grid is a massive network of power cables that link the countries together. You've probably seen those poles and the pylons with those huge cables overhead going across the country, linking towns and cities together. And the grid is powered by lots of different sources. We've got things like wind turbines, gas power stations, coal power stations, nuclear power stations, solar panels, hydroelectric dams. There's lots of different places that we generate our electricity, and they all basically release different amounts of carbon dioxide. Some of them are renewable and some of them use fossil fuels to create that electricity. So Craig, have you ever wondered where your electricity is coming from?
Yeah, I mean, is there a way that we can find this out?
Yeah, there is. There's a live data dashboard here. We can see where our electricity is coming from right this second. So
Daniel, let's look at the data. You need that catchphrase.
Here's the data. So on the left-hand side, we've got our low carbon forms of electricity: nuclear, wind, solar, and hydro. And on the right-hand side, that's our fossil fuel ones like gas, coal, and biomass. So Craig, I can see that the biggest source of electricity right now, so the electricity that's powering your projectors, your screens, the lights in the classrooms you're in right now, it's mostly coming from the wind. So 37.6% of the electricity we're using right now is coming from wind turbines. Now that makes sense to me because it's quite a windy day today.
Yeah, I
Um,
just looked out the window there. It looks windy. That kind of makes sense.
and I can see, but
So this
even on a sort of like a cold April day, we're still getting 12% of our electricity from solar panels.
Mhm. So it shows you then that, I think people might think if you live in Scotland, we don't get enough sunshine to use things like solar panels. But, in the UK, we do still get daylight, we do still get the sun. It might not be enough to cover everything, but certainly it needs to be part of that energy mix, especially if we want to use less things that are carbon intensive, things like coal, things like gas, things like biomass, and using more of the renewable sources of energy. So yeah, this data is live. This is exactly what it would be on the 7th of April 2022 at 11:22. So this data, Daniel, is it's on a website, isn't it? You're not, we're pulling this in right now, but anyone can look up this data.
Yeah, anyone could go on the website and look at the amount of electricity and where it's coming from right now. Yeah, that's a live data dashboard that's just open for anyone to take a look at. So one way that we can cut the carbon footprint associated with the electricity you're using is to install more renewable electricity. So things like more solar panels or more wind turbines, or even you could go further and have them right on your school itself. So, if you've got solar panels, could you get all of your electricity from it? Well, that's what we're going to find out.
Yeah, we asked you, do you know if your school generates electricity? So we asked you, does your school have a wind turbine or a solar panel or something like that? Daniel, let's look at the data.
Yeah, so it looks like um, it's about 50-50 actually. So
Mhm,
I can see 9 of the schools taking part aren't sure,
mhm.
and it looks like 10 of the schools don't generate any electricity. So, what that tells me that we've got at least 10 schools here that could have solar panels on the roof. They don't already have them. So I think this is going to be really useful research that you're all doing today that will help us find out, how feasible, how viable is it? What difference could that make?
So in this phase of the investigation, what you're going to do is we're going to be exploring solar energy. So our next question that we want to ask is, how much sunlight do you get at your school's location? That is really an important question for renewable energy because we need to know how much light there is that can be turned into electricity with the solar panel. So we're going to need sunlight data. In other words, we need to know how much solar radiation, how much sunlight gets to your school each day. So how could you measure this? Well, what technology could we sort of use? Well, what you could do is you could stand outside your school with a light meter. You could measure how much light there is right now, but you would have to stand out there for the whole day or the whole week or a whole year. That's far too long just to be standing outside. Or we could do it another way, Daniel.
Yeah, we could use another data set to answer the question. And you know what? I found a data set that's perfect. It tells us exactly what we need to do. So NASA, they collect lots of data about the Earth using their satellites. And NASA has a data set that can tell us how much light falls on any location on Earth across a year. So all we have to do is send NASA the latitude and the longitude of your school, and they'll respond with the data we need. So basically, we need to find out what the latitude and the longitude, the coordinates of your school is, so that we can send them to NASA to get that data. But Craig, we've made it nice and easy. We have embedded a map into the activity, and I can see quite a few of you are using that map already. So what you need to do is find your school on the map. So there's a search box. You could type in the village or the town or the city where your school is and try and find it on the map. And once you've found your school on the map, click on the building and it will drop a pin. And that will show you the coordinates of your school, ready for you to submit them to NASA so that we can get that sunlight data.
I can see some of you are already working through that just now. People from Cockenzie Primary School, Roslin Primary School's P6 data team have found the latitude and longitude for their school using the map. Amy and Erin, you're looking through some charts as well. Rebecca from Cockenzie Primary School, you've just started, but don't worry, you can catch up. Lots of people, Daniel.
Yes, I can see there's quite a few people. Oh, Jimmy at the university, you have requested data from NASA. Super. Longstone Primary School requesting data from NASA. Craig, it looks like lots of people have been using the map to find out where their school is. Craig, how do we get the data from NASA? Like, how does it? Are you emailing it them it, or is it?
So we're using what's called an API. So an API is a way that a computer programmer can access a data set that belongs to someone else. So basically, we're requesting certain bits of data and they're going to respond with that data. But we could just email them, we could send an email to NASA and say, look, can you give us this information? Can you send us it to this address? But actually that might take a couple of days. So what we're doing instead is we're using computer code to do it programmatically, which means that we can send that request and we can get a response from NASA really quickly. In fact, most of the responses that I would expect us to get this morning should take less than a second. And in fact, we've asked NASA for permission to use this today, to sort of give us priority to use this data set to make sure that it works when we're doing it live.
Yeah, so big thank you to NASA, big shout out. Thanks for letting us use your data in the activity. That's how you're getting it so quickly, because we've built it into the activity. Craig,
Wow, I can't believe, Daniel, we've had big shout outs to Dundee Council and NASA's Langley Research Centre. Brilliant uses of data there.
Yeah, and looking at the activity feed, lots of you have been getting this data, and I can see some of you are still just joining. That's okay, don't worry. You'll be able to get caught up to the same point, and the activity will move you along so that you're kept in sync with everyone else. So don't worry, you can still take part.
I can see Ethan and Robbie have got the data that they need as well, and I can see that Rachel, you found the latitude and longitude from Longstone Primary. You're going to be able to request the data next as well. More people coming in.
Yes, I can see we have R at Mackenzie Primary School. She has been telling us about the types of solar panels that's needed to generate electricity. Yeah, there's different types of solar panels. Some of them are used to heat water, some of them are used to bring light into a building, and some of them create electricity. So yeah, I can see here you told us that it needs to be a photovoltaic solar panel. That's the type of technology that we're looking at using today. Craig, some schools have actually sent us their radiation plots, and I can see, I can actually look at the data that they've requested from NASA. They've requested it and they've been looking at the chart. So let's take a look at some of these charts. So
let's look at the data.
Craig, here is the data for Pathhead Primary School. So what we're looking at here is what a typical day looks like in each of the 12 months, January to December, at Pathhead Primary School.
So the months are going along the bottom, and then the numbers going up the side. That's how much radiation, how much solar energy is arriving at that school in each month. Okay, so the higher it is, the more light there is as well. So what we've seen here, it was definitely like a curve, Daniel, isn't it? It's like it goes up and then it goes down again. So what can you understand about this data from looking at it?
Yeah, so I can see here that it's quite low in sort of like October, November, December, January, February. And then it's much higher in like April, May, June, July, August, September. And that kind of makes sense to me. Like if this is the amount of sunlight that arrives at the ground in these months, well, you'd expect there to be more sunlight on when we've got more daylight hours, or it's warmer and sunnier weather, whereas in winter where it tends to be darker or cloudier, it's much lower. There's not as much solar radiation, there's not as much sunlight that we can convert into electricity.
That's what I would expect in Scotland, April, May, June. What maybe surprises me is I kind of think of summer as being like June, July, August, and I would have thought the numbers would have been higher there. But it seems like May had the most light. Does that probably mean that, was it less cloudy in May, or was it like brighter days or something like that? That's what my guess would be.
Yeah, you're exactly right, Craig. May tends to be less cloudy. So if there's no clouds, that means the sunlight can get straight down to the ground. It's not getting blocked or filtered or kind of reduced by the clouds. So yeah, May is the highest. Let's take a look at another school, Craig. So this is from one of the pupils at Mackenzie Primary School. And, this looks really quite similar to me. It peaks in May, and then it's quite high in the summer and lower in winter.
I would kind of expect it, because those two schools are not that far apart on Earth. Like, we're in the same country, we're not that far apart, so you would expect the graph to be similar. So what that to me is suggesting that, well done, the people at Cockenzie, you've identified the right latitude, longitude. This is kind of like backing up what we're saying here, that like April, May, June seems to get quite a lot of light in Scotland. And as you say, Daniel, very similar to the other ones as well.
Yeah, exactly. And I think it does make sense that they're almost the same because they are just over the other sides of the Forth. So yeah, we've got Fife and I think East Lothian here. Here's another one, Craig. This was some pupils that were taking part, not live this morning, but the other day. This is a school in Pakistan, in Karachi, Bayview High School. Now this is quite different.
Yeah,
It
look
seems
at that.
it peaks
Like,
really
it's
in
got
May again,
two-
but then it really dips in August. It's much lower in August.
So why is it so much lower in August compared to like what I would have normally expected? Is there something about what could be causing something like that? Something to do with weather, maybe? Like, I don't know really much about the weather in that part of the world, but I know you get things like rainy seasons and monsoon seasons where it can be stormy a lot. But I don't know if is that related. That would
Yeah,
be
no,
my guess.
you've got it exactly, Craig. August is basically the center of the rainy season there, so that's when it has to be cloudy and stormy, and that blocks the sun. That creates lots of shadows on the ground. So yeah, there's just less light at that point over there.
I'm impressed with my data detective skills there, analysing that live. This is brilliant. Thank you all so much for sending in some of your graphs and your charts here. This has been really useful. We'll give you another minute or two to work through that, but I just wanted to let you to know today, remember today's live lesson, this is part of a project called Data Education in Schools. So the Data Education in Schools project is funded in part by the Edinburgh and South East Scotland City Region Deal Skills Programme, which is funded by the Scottish Government. But the point here is that you can use data science skills to work in lots of different areas. So we're using it today to look at green technology and climate change, but it can also be used in healthcare, agriculture, finance, tourism. It's used a lot in the public sector and in the creative industries too. Data skills are important across all areas of science. So maybe you're thinking that you would want to work as a scientist in a career in physics or chemistry, biology or computing science. But having data skills would be really useful for working in those areas. Having the skills, like you're doing this morning, to be able to understand that data and use it to make decisions is going to be important in lots of jobs in the future.
Yeah, Craig, there's loads of job opportunities in this area in Scotland. So according to some research by Skills Development Scotland, there's over 3,000 data scientists employed in Scotland. And the average salary for a data scientist is around £50,000 a year. In fact, it's in here, £52,000 a year. And that's about double the average salary of a worker in Scotland. So it's a really, really well paid area to get into as well. So after today's activity, you could check out the dataskills.education website for more events and activities, and you can also join their newsletter if you're a teacher or an adult. Craig, I've been looking at the data dashboard, and it looks like pretty much all of the schools have managed to get that data from NASA about how much sunlight they get. So I think we're ready to move on to the next sort of step, the next phase in our investigation.
Let's move on to that next phase.
Yeah, so
right, where have we got so far, Daniel? Where are we so far?
Yeah, we've got the data about how much electricity we need to power your school. We use that data set from Dundee. We've got the data about how much light or solar radiation there is that lands at your school, where it is on the planet. So what we now need to find out is how much of that light, how much of that solar radiation can be converted into electricity by a solar panel. We need to find this out because solar panels can't convert all of the light into electricity. We're going to have to do some sums to work out how much electricity we can generate per square meter.
Brilliant. So let's give people, Daniel, a minute or two just to work through that activity. We can bring up that data dashboard and we can see how people are getting on.
So Visit and Archie, you have looking at the efficiency values of these photovoltaic solar panels.
Jay from Longstone Primary, you chose your solar panel as well. And Ms. Giebler from Longstone Primary, you were finding out the efficiency of those photovoltaic solar panels. Good work there, well done.
Super. P6 data team at Roslin, you have been finding out the efficiency. I guess you've been looking at tables of different solar panels and choosing one. Super, good work. Keep it up.
A couple of people from Longstone Primary are already doing those sums. They're calculating the amount of electricity that can be generated per square metre. Well done, keep going with that.
So here that Mirren and Lisa at Longstone, you have found the efficiency of the solar panels that we are going to use. Those Aaron and Nicholas. TL at Nidri Mill Primary School, you've also managed to find the efficiency of the solar panels. Amy and Erin, you've chosen a solar panel. That's a really important step.
And Jimmy from the University of Edinburgh has calculated the amount of electricity that can be generated per square metre at the University of Edinburgh. This is brilliant, Daniel. All this data, all these sums are going to be coming together shortly.
Craig, I can see some people have done some sums. they've multiplied a couple of numbers together to find out how much of the sunlight can get converted into electricity. So well done to Tibby at Longstone, Caleb at Longstone, Adam and Robbie L. You weren't sure, but that's okay, because our activity works it out for you, so that's okay, don't worry. Aaron and Nicholas, you've also found out how much electricity can get converted, how much light can get converted to electricity.
Well, now that we know how much electricity could be converted, how much light could be converted to electricity, what we need to do next is calculate the size of the solar array that you might want on your school. So how big are you going to make it? So if you were going to do this manually and say you wanted it to be the size of your entire school roof, well, what we could say is, well, why don't you go and climb, get a ladder, climb onto your school roof with a trundle wheel and just measure the size of it? No, I don't think you should be doing that. Instead, we're technologists, Daniel. We're going to use computer programming to help us. We can use a geographic information system to help us. So we've got another tool, we've added another map into this activity, and it's really useful because what it's going to allow you to do is it's going to use satellite imagery and data, and it's going to let you draw a shape around your school, and it will tell you the size of that area in square meters. It's even got a data layer, so it will show you those buildings as well. So what you need to do with that map is plot the points around your school roof. So it might be the entire building, or maybe you just want a section of it, and it will tell you how big that solar panel array needs to be.
Yeah, I can see some of you are working on that already, so super. So yeah, you need to draw an area for your solar array using the map on that step. So I can see here that Jibby, you have chosen how big yours is going to be. Yours is going to be 1,340 square meters. Nidri Mill Primary School, almost as big, 1,262 square meters.
That's a big solar array.
These are big solar arrays. But then if you've got a big roof on your school, why not use it? Like, what is it? What's it doing just now? It's just absorbing all that light and it's not doing anything useful. What if we could convert that to electricity, which would lower our carbon footprint? So yeah, let's see what difference that could make. Great, we've got some answers from Longstone as well. So Ado and Robbie, the solar panel that they'd like to build is going to be 1,699 square meters.
These are brilliant. These are big, and I can see you're already working through these just now. So we know a couple of things. So once you've got like the size of, you know the amount of electricity that you could generate over a whole year using a 1 meter by 1 meter solar panel, and you know how big that area is going to be on your school roof, you've got one more calculation to do. What do we need to do, Daniel?
Yeah, so we've got two numbers that we have to multiply together. So you're going to have to get your calculators out again. And what we need to multiply is the amount of electricity that can get generated per square meter, and then the size of your solar array, which is in square meters. And that's going to tell us, final answer, that's going to tell us how much electricity could be generated by solar panels, like the size of your school at your school's location, considering the weather where it is in the planet. Like, this is the real data, this is the real numbers. And Craig, I'm looking at these here. This is quite a lot. These are good numbers. I'm not going to spoil it, but I'm impressed.
Let's give people another minute then or so to work through this, and then we'll have a look at some of these answers.
So Bob, you've done that calculation of how much electricity can get generated on each square meter. Michael, you've done the calculation as well. Amy and Erin, you've measured the area on your school roof.
The P6 data team have been drawing out their solar array too. How big it's going to be, that's great. And I can see some of you are starting to do those solar sums, those calculations as well. Well done.
Super.
I think we give people another, 30 seconds, Daniel, or so at least?
Yeah, let's give people another 30 seconds, another minute to do that calculation. Maybe you've got to dig out your calculator or open up the calculator app.
Yeah, there'll be a calculator app built into your computer. You can use that. You don't have to do it in your head. You don't have to do it on paper. We're data scientists. We're going to use technology to help us. Just looking at some of these answers as they come in here, Daniel, as well. This is great. We're seeing all your numbers come in. This is so impressive. There's so much energy potential, electricity potential across the roofs of schools across Scotland. Daniel, can we have a look at some of these?
Yeah, we can. So let's take a look at some of the results. So this is from one of the pupils at Cockenzie, and they have calculated that solar panels on the roof of their school could generate 716,000 kilowatt hours of electricity per year. Now, I'm an engineer, I know that's a huge number, but let's think about what we could actually do with that. Craig, we could charge 59 million iPhones, or you could power 85 computing classrooms for a year.
That is a lot of electricity.
Yeah. Or you could drive an electric car from Edinburgh to Dundee 48,000 times.
Hang on, so what you're saying, Daniel, is that if Cockenzie Primary School had a solar panel on the roof of their school that covered the entire roof, then that would give them enough electricity to drive from Edinburgh to Dundee 48,000 times?
Yes.
That's a lot. That's
that
great.
A lot. That's or 85 computing classrooms. You know, they could power the whole school with that amount of electricity.
Interesting. So it shows you then that, we do have the potential to calculate energy, but it's who else have we got here? What school's this?
Yeah, so this is Pathhead Primary, and you know what, their numbers are quite similar. It's just a wee bit lower. Maybe their roof's a bit smaller. So they've calculated that they could generate 575,000 kilowatt hours of electricity over a year. So that'd be 68 computing classrooms, or driving from Edinburgh to Dundee 38,000 times.
That's great. I can see, Daniel, we've had some tweets coming in as well. P7 really enjoying doing it from, let's see what school that is. Primary school. I'm not sure which primary, but P7 are enjoying it as well. And Mr. Burt, who's a primary school teacher at Roslin, has been using live data to solve problems. Thank you very much for sending in these pictures as well. It's great to see. I can actually see the Primary 6 data team here, Daniel, working through the activities. This is brilliant.
That's excellent.
Daniel, collectively, we could put some of these numbers together, like everyone who's taken part today across all these schools in Scotland. What if we were to sum up that total of energy? What could we achieve together?
Yeah, so I think we've got 7 or 8 different schools that have been sending in their calculations, their numbers. And so if we add all these up together, all of those new solar panels that we could be fitting, that could power.
I know. I'll put that through. Hang on. Just update the
Wow.
spreadsheet. Hang on. That's a lot.
That's
A big number.
Right, okay, thanks, Craig. I can see that would be 12,805 light bulbs continuously 24/7 for a year. That's like 6 Blackpool Towers worth of light bulbs, Craig.
I love that unit of measurement. 6 Blackpool Towers
Yeah, it's
worth
the
of
double-decker
light
bus
bulbs.
measurement.
So this is what's really interesting about data science here. What we're doing is we're exploring and we're trying to find the answers to questions. So, one of the things might be, why don't we all do this then? So why don't we have solar panels on every roof in Scotland, in every school roof in Scotland? Why are we not doing this all the time? It's not as straightforward necessarily as just saying, well, look how much electricity we could get. The thing that we haven't spoken about is how expensive it might be to get things like solar panels put on the roof. And at the moment, I think the price is roughly about £250 per square metre. So that's a lot of money for the size of some of the solar panels that you're planning at the moment. However, if we had more people who had these green technology skills, who knew ways that we could build solar panels cheaper, or we could make them more efficient. So you were saying earlier, the answers you were coming in saying that the solar panels we were using at the moment was about 20% efficient. What if we could develop ones? What if we had more scientists and researchers who were making them at 50% efficiency, something like that? That would make a massive difference. We'd be able to get even more electricity and more energy out of it as well. And what if we had better ways of storing the electricity as well, Daniel? Like, it's all very good in bright months, but what would we be doing in the winter when we're maybe not getting enough we're not getting enough sunlight to power the school for the whole day? These are things that we've not addressed today, but would be worth you exploring in the future, working out, okay, what have we not taken into account, and can you find the data that would help you answer those questions?
Yeah, exactly. Like, we have proved that, if we could afford it, solar panels would make a huge difference to the amount of like carbon dioxide that we'd be creating. Like, adding solar panels to the roof is one of the best ways that you can reduce the carbon footprint of a building, because it means you don't have to burn the coal, you don't have to burn the gas or the oil to create the electricity. It's green, it's coming just from the sunlight. But yeah, solar panel prices are getting cheaper. More people are going into this area, there's more people working on it, and the technology is getting better. So I reckon if we were to do this activity again next year, the year after, probably more schools would have solar panels fitted, because it is a really effective way of reducing your carbon footprint.
Well, now you've got the evidence as well to prove that to your school. You could show them how much electricity potential there is on your school roof. You've looked at the real data. You've based it on data from NASA, from Dundee City Council as well. So well done. Oh, yeah. This has been really good.
You really have been part of our data science team, and thank you for being part of that and doing the numbers, plugging those numbers in. We couldn't have worked out all of this without your help today. You've given us basically like 8 proposals worth of information about solar panels, and I hope this has got you thinking about how we can use data to answer big problems that we're facing, like reducing our carbon footprint. Now, Craig, there's one more task that we need everyone to do, and it is an important one. We need you to answer some questions about today's event and tell us what you thought about it.
Yeah, so you're going to click on the link and you're going to answer the questions that come up on your screen. Now, we're on YouTube today, Daniel, so we need to say it. You need to, if you're a teacher and you're watching this, you need to like this video, you need to subscribe to our channel, and you can see all our future data science interactive activities. If you are a teacher, also, you could take a photo of your report card. You can tweet it to us at data_schools, and you can use the hashtag #DataSkillsLive. We've had so much fun plugging in the numbers with you today. Why don't you try out one of our other data science activities after lunch? You could code your own data selfie, or you could defend the rhino with data science. Go to our website, cyberskillslive.com.
But for now, that's us at the end of our live session today. So thank you very much for joining us. Thank you for taking part. And it's bye from Sunny. Yep, she's saying bye. And it's bye from Craig.
Bye-bye.
And it's bye from me as well. See you next time. Bye. off.